Hey there, nursing students. Welcome to today's Explainer. I'm your lead nurse researcher, and together we're going to master the data types that literally form the bedrock of all evidence-based practice. If you've ever stared at a patient's chart and just wondered how all those random numbers and scribbled notes actually transform into life-saving medical research, well, you are in exactly the right place. Today, we aren't just memorizing dry definitions. We're unlocking the actual language of clinical research.
Okay, let's take a quick look at our syllabus for today. We'll be covering 1. Tracking the patient journey. 2. Qualitative versus quantitative data. 3. The 4 levels of measurement. 4. Selecting appropriate statistical tests. 5. Improving clinical care decisions. And we'll wrap it all up with number 6, a nursing statistics knowledge check.
Section 1. Tracking the patient journey.
You know, to really understand data, we first have to understand how we actually capture it out there on the floor. And clinical data classification has evolved dramatically. Back in the 1980s, we relied super heavily on basic manual records, just massive stacks of paper files that made large-scale research incredibly tedious. Then, by the 2000s, we transitioned into using extensive but definitely time-consuming paper questionnaires. Now, today, in the 2020s, we're operating in the era of electronic health records, or EHRs. These systems use pre-populated templates to streamline data entry and can even trigger life-saving alerts. But here's the catch. For an EHR to actually work its magic, the data we feed into it has to be perfectly classified. Let's bring this to life by following a hypothetical palliative care patient. We'll call him Mr. Davis. His intake data gives us the perfect case study. So when Mr. Davis is admitted, the intake nurse records his body temperature, his diabetes status, his current cancer stage, and his resting heart rate. Now, as a nurse researcher looking at Mr. Davis's chart, you shouldn't just be seeing a patient profile. You're actually looking at a complex mix of very different statistical variables.
Moving right along, Section 2, Qualitative versus Quantitative data.
All right, so our very first task as researchers is dividing Mr. Davis's data. This is literally the first fork in the road for any statistical analysis. We have to decide if the data represents categories varying in quality or numerical scales varying in magnitude. Qualitative data, which is also known as categorical data, simply describes an attribute or a quality. Quantitative data, on the other hand, represents an actual measurable quantity. Think about it this way. Things like a patient's surgery type or a history of myocardial infarction, heart attacks, those are qualitative. They're distinct categories, right? You either had a heart attack or you didn't. On the flip side, measurable numbers, like Mr. Davis's body temperature in Celsius or his heart rate in beats per minute, are quantitative. They have a true, measurable, numerical magnitude.
Which brings us to Section 3, the 4 levels of measurement.
Okay, this is where we get a bit more granular. And honestly, it is absolutely crucial that you do this step before running any math. You can remember these levels with the acronym NOR: nominal, ordinal, interval, and ratio. As you move from nominal all the way up to ratio, the data becomes way more complex and precise. We determine the level by looking for 4 specific characteristics: distinctiveness, ordering in magnitude, equal intervals, and an absolute 0. Let's see how NOR actually builds using our patient, Mr. Davis. His diabetes status? That's nominal data. Nominal literally means name. It's a simple yes or no category without any kind of numerical ranking. One category isn't higher or better than the other in a math sense. Whereas his cancer stage, say stage 1 versus stage 4, is ordinal data. It has an inherent rank of severity. We all know stage 4 is more advanced than stage 1, right? But the mathematical difference between stage 1 and 2 isn't necessarily the exact same as the difference between stage 3 and 4. The order matters, but the intervals between them are imprecise. Now, let's compare the quantitative side. His body temperature in degrees Celsius is interval data. The units are equally spaced, meaning the difference between 36 and 37 degrees is the exact same as the difference between 38 and 39 degrees. But, crucially, the 0 point is entirely arbitrary. A temperature of 0 degrees Celsius does not mean an absolute absence of heat. However, the number of hospital visits Mr. Davis has had, that is ratio data, because 0 represents a true absolute absence of visits. You can't have negative hospital visits, and 4 visits is exactly twice as many as 2 visits.
But what about the really subjective stuff? The crucial point is how we handle subjective patient experiences, like fatigue or pain. To do that, we use Validated Patient-Reported Outcome Measurements, or PROMs, to accurately classify these patients' symptoms into measurable data scales. For example, the Edmonton Symptom Assessment System, or ESAS, queries 8 physical symptoms plus mood. Then there's the distress thermometer, which uses a 0 to 10 scale, giving us ordinal data for psychological distress. And the Integrative Palliative Care Outcome Scale, or IPOS, brilliantly combines physical symptoms with psychosocial domains. These tools are amazing because they take messy, qualitative human suffering and translate it into structured data that we can actually study.
All right, Section 4, selecting appropriate statistical tests. So, why does penning down these NOR data types actually matter when you hit the analysis phase of your nursing research? Simply put, the data type chooses the map. Think about it. You just cannot calculate a mean or an average for a nominal variable like diabetes. It makes absolutely no sense to say the average diabetes of a patient group is 0.5. Instead, for nominal data, you can only look at frequencies and proportions, like observing that 8.2% of females in a study group have diabetes compared to 8.9% of males, and we'll get into these how-it-hows when we get to the analysis phase. It maps out perfectly like this. Your data type strictly dictates your statistical test. Because we look at proportions for nominal data, like diabetes status, we have to use tests designed specifically for proportions, like a chi-square or Fisher's exact test. But if we're looking at continuous, ratio-level data, like body mass or heart rate, we can calculate means and standard deviations. And that opens the door to completely different tests, like the two-sample t-test or linear regression. Basically, if you use a continuous data test on categorical data, your research is fundamentally flawed right out of the gate.
Almost there. Section 5, improving clinical care decisions. Now, I know all of this abstract statistical theory can feel a bit dry, but it has very real clinical stakes for patients like Mr. Davis. This isn't just about passing a statistics exam, it is literally about patient survival and comfort. When we accurately measure and classify data from those symptom assessments we talked about earlier, like the IPS or distress thermometer, we can feed that pristine data into AI-based clinical decision support systems. As researchers have pointed out, integrating this accurately classified PROM data can drastically improve patient stratification. It allows systems to automatically flag patients who urgently need palliative care interventions, saving nurses valuable time and vastly improving the patient's quality of life.
And finally, Section 6, nursing statistics knowledge check.
Let's wrap up this module by putting on your researcher hats for a second. Imagine you're building a database for a brand new clinical trial. Think about how you would classify specific clinical variables, like what about a patient's race or ethnicity, their age, the number of medications they're currently taking, or maybe their score on an SF-36 short-form health survey. Think about whether they're qualitative or quantitative, categorical or numerical, and most importantly, exactly where they fall on that NOR scale. All right, let's see how you did. Race or ethnicity? That is classified as nominal, distinct categories with no inherent mathematical rank. Age and the number of medications, those are ratio data. They are continuous or discrete numbers with a true absolute 0. Meanwhile, a subjective chest-wrenching-ogram score is ordinal. The stages definitely have a rank of severity, but the mathematical distances between those scores aren't perfectly equal. As you head back out into the clinic and begin your own research projects, I really want you to consider this final thought. If a misclassified data type leads to the wrong statistical test, how might that flawed evidence ultimately alter a patient's final care plan? Remember, behind every single nominal, ordinal, interval, and ratio data point is a real patient, just like Mr. Davis, relying on our precision. Master your data types, choose the right tests, and let the evidence lead the way. Thank you so much for joining me on this explainer.